Good morning, students. So today our topic is we are going to find the condition for two given lines to be coplanar. Okay, so we are going to see the condition in vector form as well as in the Cartesian form. So coplanar, so the two lines are coplanar means they lie on the same plane. Okay, so here we are going to say the condition for coplanarity of two lines. So first we are going to see in the vector form. So here I have considered a plane. So on that I'll consider the two lines L1 and L2. This L1 and L2 lie on the same plane. So I'll call these two lines are coplanar. So L1 equation is R vector is equal to A vector plus SB vector. And the second line L2 equation is R vector is equal to C vector plus TD vector. Okay. So L1 passes through the point A whose position vector is A vector, and L1 is parallel to B vector. The same way second line passes through the point C whose position vector is C vector, and this L2 is parallel to the vector D vector. Okay. So see now here A is a passing point of the first line. So C is the passing point of the second line. Okay. So A and C lie on the plane. Okay, you look at this, since your B vector and D vector, they are parallel to the plane. B vector and D vector, they are parallel to the plane. So, the cross product of them, what is it? B vector cross D vector. So, how it will be? It is perpendicular to AC vector. So B vector cross D vector is perpendicular to AC vector. Okay. So any two vectors are perpendicular, their dot product is equal to 0. So AC vector dot B vector cross D vector is equal to 0. Okay, AC vector how you can write? It can be written as OC vector minus OA vector dot B vector cross D vector is equal to 0. What is OC vector? So it is nothing but C vector. What is OA vector? It is nothing but A vector. So C vector minus A vector dot B vector cross D vector is equal to 0. This is the condition for the two lines to be coplanar. Okay, so now we are going to see the condition in Cartesian form. Okay, the first line can be written as x minus x1 by b1 is equal to y minus y1 by b2 is equal to z minus z1 by b3. And the second line is x minus x2 by d1 is equal to y minus y2 by d2 is equal to z minus z2 by d3. They are coplanar. If, what is the condition? You see that here we have in the vector form what we have written, C vector minus A vector dot B vector cross D vector is equal to 0. So here you are having dot product, in between these two vectors you are having a cross product. So it is a scalar triple product. So how to evaluate scalar triple product? It is nothing but the determinant. Okay, so what is the first vector? C vector minus A vector. What they are? They are the position vector of the passing points of these two lines. Position vector of the passing points of these two lines. Okay, so it can be written as, the second point C can be written as x2, y2, z2, and the first point A can be written as x1, y1, z1. So therefore, what is C vector minus A vector components? x2 minus x1, y2 minus y1, z2 minus z1. And then what is the second vector is present here? It is B vector. So they are the parallel vectors. So therefore B1, B2, B3. The next one, what is it? D vector. So whose components are D1, D2, D3 is equal to 0. So this is the condition for two given lines or coplanar. Okay, so in the vector form the condition is C vector minus A vector dot B vector cross D vector is equal to 0. In the Cartesian form, determinant x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3 which is equal to 0. Okay, so next we are going to write the equation of the plane containing two non-parallel coplanar lines. Okay, so we are going to write the equation of the plane containing two coplanar lines. So both the lines lie on the same plane. So we can use the position vector of the passing points of the lines and the parallel vector. Okay, so see that idhula parametric form of vector equation we are going to take. You see that from the first line we can collect A vector and B vector. A vector is the position vector of the passing point and B vector is the parallel vector. From the second line we can take the position vector of the passing point of the second line and the parallel vector of the second line. So we will have position vectors of two passing points and two parallel vectors. But to write the equation of the plane, so we need only three vectors. So here we are going to take one passing point and two parallel vectors. Okay, so one passing point, that A vector, if I take the passing point from the first line, it is denoted as A vector, and B vector is the parallel vector of the first line and D vector is the parallel vector of the second line. So if we take the passing point from the first line and one parallel vector from the first line and another parallel vector from the second line, means the parametric form of vector equation is R vector is equal to A vector plus T B vector plus S D vector. Otherwise, we'll take the passing point from the second line, means we can write R vector is equal to C vector plus T B vector plus S D vector. So non-parametric form of vector equation of the plane containing coplanar lines. Okay, you see now here also we take one passing point and two parallel vectors. So the non-parametric form is R vector minus A vector dot B vector cross D vector is equal to 0. Or otherwise, if we take the passing point from the second line, so the non-parametric equation can be written as R vector minus C vector dot B vector cross D vector is equal to 0. So next we are moving to the Cartesian equation of the plane containing two coplanar lines. So here we are going to use the formula one passing point and two parallel vector. So it is a determinant x minus x1, y minus y1, z minus z1, b1, b2, b3, d1, d2, d3 is equal to 0. Or if you take the passing point of the second line, it can be written as determinant x minus x2, y minus y2, z minus z2, b1, b2, b3, d1, d2, d3 which is equal to 0. Using these results, we are going to do the problem exercise 6.8. First problem, show that the straight lines, first straight line and the second straight line are coplanar. Find vector equation of the plane in which they lie. Okay, so two straight lines are given. We have to show that the two straight lines are coplanar and you have to find the vector equation of the plane where the lines lie. Okay, so see, from the first line we have to collect A vector and B vector. Okay, A vector is nothing but the position vector of the passing point of the line and B vector is a parallel vector. So here I have written A vector, B vector from the first line. The same way, from the second line you have to collect C vector and D vector. So C vector is the position vector of the passing point of the line, and D vector is the parallel vector of the line. So I have collected A vector, B vector, C vector and D vector. So what do you have to show? The two lines are coplanar. So here the equations in the vector form. So I am going to use the condition for coplanarity of two lines is, what is it? C vector minus A vector dot B vector cross D vector is equal to 0. So from this we can find B vector cross D vector, then you can apply in this formula. So otherwise we can write it is a scalar triple product. So you can evaluate using the determinant x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3 is equal to 0. Both are same. It is in the vector form. It is in the Cartesian form. Okay. So here I have to write x2 minus x1. So this is A vector components are written as x1, y1, z1, and C vector components are x2, y2, z2, because they are nothing but the position vector of the passing points of those two lines. So here you see, now here we have to prove it is equal to 0. For that you are considering only the left hand side. So in that left hand side you have to write the first row, that is x2 minus x1. Okay, look at this. So your x2 is 8. Okay, x2 is 8 and x1 is 5. So 8 minus 5. So here I have written 8 minus 5. And then y2 is 4 and y1 is 7. So it is 4 minus 7. And here z2 is 5 and z1 is minus 3. So how it will be subtracted? 5 minus of minus 3. So it is 5 plus 3. Then next what do you have to write? You have to write b1, b2, b3. What is it? It is the components of the parallel vector B vector. So what is here? 4 comma 4 comma minus 5. So I have written. Okay, next one d1, d2, d3. It has to be taken from D vector components. So it is 7, 1, 3. Okay, so when you evaluate, 8 minus 5 is 3, 4 minus 7 is minus 3, 5 plus 3 is 8. Okay, so when you expand by R1, you will get the answer as 0. So what we have taken? So we have considered this determinant. Finally, we arrived that whose value is 0. So our condition is satisfied. So therefore the given lines are coplanar. So first result we have completed. We have shown that the two lines are coplanar. Now what is asked? It is find the vector equation of the plane in which they lie. So we have to find the vector equation. So the vector equation of the plane containing the two coplanar lines. Okay, so either you can use this formula, r vector is equal to a vector plus sb vector plus td vector, or r vector is equal to c vector plus sb vector plus td vector. So a vector, b vector, d vector has to be substituted and you will get this answer. Okay, so we'll come to the problem number 2. Show that the lines, two lines are given or coplanar, the same thing. Also find the plane containing these lines. Okay, so it is in the Cartesian form. So I am not going to take the vectors a vector, b vector, c vector and d vector. So in the Cartesian form itself I am going to take. So I have to collect the passing point of the first line and the parallel vector of the first line. The same way from the second line I have to collect the passing point and the parallel vector. Okay, take the first line, the numerator x minus x1, y minus y1, z minus z1. So the point, what is it? 2, 3, 4 is nothing but x1, y1, z1. And the denominator, so what is it? 1, 1, 3, they are nothing but b1, b2, b3. So in the same way from the second line, so here the points are passing points are 1, 4, 5. Okay, and that from the denominator, what is it? Minus 3, 2, 1. That is nothing but d1, d2, d3. So what is the condition for the two lines to be coplanar? In the Cartesian form, it is nothing but determinant x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3 is equal to 0. So here we have to show that they are coplanar. So you consider the determinant and substitute the values. Okay, while you are substituting the values, you are getting this. See now, x2 minus x1, so 1 minus 2. At the y2 minus y1, 4 minus 3. z2 minus z1, 5 minus 4. And b1, b2, b3, d1, d2, d3 is substituted. So when you simplify, you will get the answer as 0. So the condition for the coplanarity of two lines are satisfied. So therefore the given lines are coplanar. Now you are going to find the equation of the plane. Okay, so the equations are in the Cartesian form. So we are going to take the equation of the plane in the Cartesian form. So you have two formula. If you consider the passing point of the first line, you can write the determinant x minus x1, y minus y1, z minus z1, b1, b2, b3, d1, d2, d3, which is equal to 0. Okay. Here x minus x1 is 2 and y minus 3 and z minus 4. b1, b2, b3, d1, d2, d3, which is equal to 0. When you expand by r1, so you will get this answer. So here if you divide it by minus 5, you will get x plus 2y minus z minus 4 is equal to 0. Third one, if the straight lines x minus 1 by 1 is equal to y minus 2 by 2 is equal to z minus 3 by m squared, and x minus 3 by 1 is equal to y minus 2 by m squared is equal to z minus 1 by 2 or coplanar. Find the distinct real values of m. So what is given? That the two lines are coplanar. So if the two lines are coplanar, so we know that x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3, whose determinant value is equal to 0. So now we have to collect the results. What is x1, y1, z1? It has to be taken from the first line. It has to be taken from the first line numerator. So the answer is 1, 2, 3. Okay. So x1, y1, z1 is 1, 2, 3. Next, from the denominator, what are nothing but? They are nothing but b1, b2, b3. So therefore it is 1, 2, m squared. Okay. So go to the second line. So from the numerator, what you are having? 3, 2, 1. Okay, they are nothing but the passing point of the second line. So it has to be denoted as x2, y2, z2. From the denominator, if you collect 1, m squared, 2, they are nothing but the parallel vectors. Okay, so it is d1, d2, d3. So you have to substitute in the condition. So it will be x2 minus x1, that is 3 minus 1. Here y2 minus y1, 2 minus 2. Next 1 minus 3. And b1, b2, b3, d1, d2, d3, which is equal to 0. So when you simplify, 3 minus 1 is 2, 2 minus 2 is 0, 1 minus 3 is minus 2. While you are expanding by r1, so you will get this answer. Okay, so here it will be evaluated. 2 4s are 8 minus 2 m power 4 minus, this is 0, minus 2 into m squared minus 2m squared, minus 2 into minus 2 is plus 4 is equal to 0. So minus 2m power 4 minus 2m squared, 8 plus 4 is 12, divided by minus 2. You will get m power 4 plus m squared minus 6 is equal to 0. It is a quadratic equation in terms of m squared. So when you take the product of two numbers should be minus 6 and the addition of those two numbers is 1. So we'll have 3 and minus 2. So it is a quadratic equation in terms of m squared. So we can write m squared plus 3 into m squared minus 2 is equal to 0. So when you equate to 0, m squared is equal to minus 3. So m is equal to plus or minus square root of minus 3. So it can be written as root 3i. So if you have I along with I, it is not a real number, it is a imaginary number. Okay, take the next one. M squared minus 2 is equal to 0. So m squared is equal to 2, m is equal to plus or minus square root of root 2. Here in your problem, what is asked? Find the distinct real values of m. You want the real values. So the real values of m are plus or minus root 2. Okay, so come to the fourth problem. If the straight lines, two straight lines are given, they are coplanar. So they have given that they are coplanar, and find lambda. So we have to find the value of lambda and equations of the plane containing these two lines. So we have to write the equations also. Given that the two lines are coplanar, so therefore the two lines has to satisfy this condition. Okay, for substituting this condition, we need the points. So we have to collect x1, y1, z1 from the numerator of the first line, that is 1. Here you will have minus 1. Because it should be how it should be, y minus y1, like that it should be. So it is, in the plus can be written as y minus of minus 1. So we have to take minus 1. Here z minus z1. So z, here you will have only z. So we can write z minus 0. So x1, y1, z1 as 1, minus 1, 0. And from the denominator, we have to collect the direction ratios of the parallel vector, that is b1, b2, b3. And the same way, from the second line, we have to collect from the numerator the passing points x2, y2, z2. So what will be here? In between you are having plus, so it should be minus 1. Here also minus 1, here 0. And from the denominator, we have to collect d1, d2, d3. Okay, so you have to substitute in this condition. So I have substituted here, which is equal to 0. So minus 1 is minus 2. Minus 1 plus 1 is 0, 0. So when you evaluate by expanding by r1, you will get minus 2 into, delete the first row in the first column, you will have lambda squared minus 4, which is equal to 0. The other two elements are 0. So minus 2, when you take it to the next side, it is 0. So lambda squared minus 4 is equal to 0. Lambda squared is equal to 4. Lambda is equal to plus or minus 2. Here lambda, we are getting two values. And what is asked? Find the equations of the plane containing these two coplanar lines. So equation we can take. So the lines are in the Cartesian form. So I have taken the determinant x minus x1, y minus y1, z minus z1, b1, b2, b3, d1, d2, d3 is equal to 0. Okay. So first we have to consider lambda is equal to 2. So when you substitute the values, what is your x1, y1, z1? What we have taken 1, minus 1, 0. So when you substitute, it is x minus 1, y plus 1, z minus 0. What is b1, b2, b3? 2 lambda 2. So we have to substitute here. d1, d2, d3 is nothing but 5, 2 lambda. So here we have substituted. Okay, so see now here in the place of lambda you have to write 2. So here 2, here also I have written 2. So when you expand by r1, so you will get this answer as 6y plus 6 minus 6z is equal to 0. When you divide it by 6, you will get y minus z plus 1 is equal to 0. So next we have to take the lambda is equal to minus 2. So what is asked? The equation of the plane. So we have substituted and we have written this. This is the equation of the plane. So in the place you have to substitute now. Your lambda is equal to minus 2. So you will get this determinant. When you expand by R1, you will get the answer as 14y plus 14 plus 14z is equal to 0. When it is divided by 14, you will get the answer as y plus z plus 1 is equal to 0. Thank you, students.